today's session, we are going to discuss about virtual sequence and virtual sequencer concept. Okay, why it is needed, how to implement those concepts. Okay, before. So virtual sequence is a sequence whose purpose is to manage the behavior of the sequences on other sequencer. Okay, that means this is the architecture. So in this architecture we have a DUT, okay, that supports three interfaces. One is APP interface, wishbone interface, PCIe interface. Okay. Generally we use APP interface to programming the registers which is available in the DUT, and the wishbone interface to transfer the data between the DUT and peripherals. Then PCIe is used to access the memory related things which is present in the DUT. So for each interface, we need different agents. For example, for this APP, I have AVP agent here, and here I have wishbone agent, and in the same way I have PCI environment or agent. So this everything will be instantiated inside the top environment, that is UVM environment. So here we have the different sequences. So M wishbone reset sequence. So in the same way, you have APP write sequence, APP read sequence, and wishbone write sequence. So multiple sequences are available. So this virtual sequence, okay, it is a container class, okay, that consists of multiple sequences. Okay. This will decide whether this virtual sequence will decide which sequence has to pass to the which sequencer. Now, for time being, neglect this red color box. This is a virtual sequencer. Now, I am going to explain about virtual sequence. Okay. So, this virtual sequence will decide which sequence has to pass on the which sequencer. For example, this M wishbone reset sequence, I need to pass through the sequencer which is available in the wishbone agent. Okay. So, that I mentioned here. In virtual sequence, I will mention this sequence M wishbone reset sequence should pass through this M wishbone sequencer, okay, and it reaches to DUT. So this I can mention in the virtual sequence. Okay. A virtual sequence is a sequence whose purpose to manage the behavior of the sequences, okay, on other sequencer. So which sequence has to pass to the which sequencer, that is decided by the virtual sequence. Okay, the need for virtual sequence rises whenever we have to run different sequences or different environment. Okay, in this example, you see we have different environment or different agent. Okay, here PCI is a separate environment we are looking here, and we have different agent, right? So when we want to pass the sequences, different sequences, or in the different agent or different environment, we have to use the virtual sequence concept. So virtual sequence is a container class to start multiple sequences on different sequences in the environment. So to implement this virtual sequence concept, there are two approaches. Okay, the preferred one is first approach, and few projects they implemented second approach also. So you should learn both the approaches. The first approach we are using only virtual sequence. Okay, will contain itself a handle of agents sequencer on which the subsequence are to be executed. So here in virtual first method, the virtual sequence itself will have the handle of the sequences which is present in the multiple agent. In second approach, virtual sequence will run on the virtual sequencer. A virtual sequencer we have to implement. This extends from UVM sequencer. Here the virtual sequencer will contain the target agent sequences. So in the first method, the agent sequences handle will available in the virtual sequence itself. Here in second method, inside the virtual sequencer, we are getting the handle of all the sequences, and this virtual sequencer handle will be called in the virtual sequence. Okay. First we will see the first approach, that is a virtual sequence. Only virtual sequence we can able to implement the concept. So first we have to write the virtual sequence. Before that we have to write these sequences. Okay. So assume that we have ABB write read sequence, wishbone reset sequence, PCI generate sequence, everything available in the sequence. Okay. This sequence we have to write separately. Then we have to write the virtual sequence. So in this virtual sequence, it is extended from UVM sequence and take UVM object details. It is a sequence, right? So it is an object, not a component. So you should register this UVM virtual sequence to the factory. Then in the first approach, you should declare all the all the sequencer and the sequences, okay, which is available in the design, test bench design. So this ABB sequencer is available inside the ABB agent, right? So you have to declare all the sequences which is available, okay? And also all the sequences. So I mean, what are the sequences you are going to use? So those sequences you have to declare here. Okay? Then in pre-body, or you can use build phase. Okay, in the build phase, to create object for all the sequences, not a sequencer. The sequencer will be built while the agent got built. In the environment, you are calling the agent. So while the agent get built, so the subcomponents like monitor, driver, and sequencer will be created. Okay. So here you have to create object for the sequences. Okay. Then in body method, you have to mention which sequence dot start sequencer. Okay. This sequence will pass to the sequencer, this sequencer. Okay. So usually we mention this one in the test, right? So in early test. Now in virtual sequence concept, this you should mention here. Okay. In test we have to mention null. Okay, that I will explain next time. So here in the body method, you have to mention which sequence has to pass to the which sequencer. Okay. So likewise, you have to mention all the sequences along with the sequencer. Then in test, so you have to instantiate in the run phase or in the build phase. Okay. You have to instantiate the visual sequence. Okay. It is M sequence. Okay. Using create method, can create an object for the visual sequence. Then here this sequences, okay, which is present in the virtual sequence. Okay, it does not know where is the actual sequence is present. Here we are instantiating the ABB sequencer, but we don't know where is this ABB sequencer is present. So that we have to assign in the test. So in test, once you create an object for the virtual sequence, then you have to map the sequencer. MVC. So this is the handle of virtual sequence. Inside that I have MAPP sequencer. See here, this one MAPP sequencer is available inside the virtual sequence. So this is the I declared. Okay. So the actual location of the sequence is available inside the environment, inside the ABB agent. Inside that I have the ABB sequencer. So this I have to map it for this sequencer. The same way you have to map the remaining sequencers also. M-bridge sequence. So where it is present inside the agent, you see the diagram. We take this one. So where this is present inside the environment, inside this agent, I have bridge sequencer. So this I have to map in the test. Then at last you have to mention the virtual sequencer, sorry, virtual sequence dot start. Here you should mention null because we already mentioned it here. Okay. This sequence has to pass through this sequencer, so you have to mention null. So automatically these sequences are passed to the this sequencer. Then in second approach, we are using virtual sequencer. We are using virtual sequence. Along with that, we are using virtual sequencer. Here the difference is, in the first approach, the virtual sequence itself have the handle of the virtual sequencer. Sorry, not a virtual sequencer. Virtual sequence itself have the handle of all the sequences, okay, which is available in the other agent and environment. But in virtual sequencer, we are implementing a virtual sequencer. Here, it will have the handle of the other sequencers. Okay. So first you have to write the virtual sequence. Okay. So the difference is here we don't have the handle of the other sequencer. Okay. Here we have only the handle of sequences. Okay. So here we have to declare all the sequences we need to run, and in pre-body method or a build phase you have to create an object for all these sequences, and in task body you have to mention which sequence is passed to which sequencer. Okay. Here P sequencer is the default handle of virtual sequencer. To get this handle, we should declare the virtual sequencer with this macro. Tick UVM declare P sequencer. It is a macro available. You should declare the virtual sequencer with this macro. Then only you can able to use this P sequencer. So the P sequencer is nothing but a handle of virtual sequencer. Okay. So I already told the virtual sequencer, this name of the virtual sequencer, my virtual sequencer, it contains all the sequencers handle. Okay. So with the help of the handle, you can able to access the sequencer. So in virtual sequence, I have to mention sequence dot start sequencer. So you have to mention where is the sequencer is present, which is present inside the virtual sequencer. Okay. P sequencer is the handle of virtual sequencer. Inside that, I have the handle of M ABB sequencer. Then need to write the virtual sequencer. Okay. Virtual sequencer name is my virtual sequencer. It is external to UVM sequencer. You have to register this to the factory, and this is the function you constructor for this virtual sequencer. Here you have to declare all the sequencer which is available in the architecture. Okay. So that you have to instantiate here. So this one we are calling the virtual sequence. P sequencer dot ABB sequencer. Then this virtual sequencer should be create. We have to build that one, right? So that we have to do in the top environment. Okay. Inside the top environment, you have to instantiate the virtual sequencer. Okay, yes, M virtual sequencer, and in build phase you have to create an object for this, for the virtual sequencer, and in connect phase we should map, okay, the virtual sequencer containing the other sequencer, but we don't know, okay, where is this actual sequencer. This is nothing but a handle. Okay, it is a declaration, but we should map this with the actual location. Okay, so that we are doing in the top environment. So in the environment, M virtual sequencer is the instance. Okay, for the virtual sequencer. Inside that, I have this sequencer handle. For this, I am assigning the actual handle. Actual handle where it is present in the APB agent. So now I am in the environment. The below hierarchy I have agent. So APB agent dot APB sequencer. The same way I have to map the actual location of the sequencer to this handle. Okay. And then in test, okay, we are instantiating the environment, and in test you have to, in run phase or in build phase, you have to create object for the virtual sequence, okay, and we have to start virtual sequence handling, okay, m virtual sequence dot start virtual sequencer. So virtual sequencer is available inside the top environment, right? So m environment dot virtual sequencer. So when you give like this virtual sequence, in body method we mentioned which sequence has to pass to the which sequencer, okay. So it will automatically go to that virtual sequence, and there we mapped the virtual actual sequence for the sequencer, okay. So it will pass to the corresponding sequencer, so the transaction will happen. To understand this virtual sequence and virtual sequencer concept, we will take a small example of FIFO, okay. So here the FIFO design test bench architecture, you divide the FIFO environment. So inside the environment, you have only one agent, right? So that you divide it into two agents. Okay, one is you can name it as master agent. Another one you can name it as a slave agent. Okay. So master agent consists of sequencer, driver, and monitor, and the slave agent consists of sequencer, driver, and monitor. So you have to create sequences. Okay, one is with the help of sequence item, you can create a write sequence, and one is read sequence. So use this master agent only for write. Okay, for FIFO write you can use this master agent, and for FIFO read you can use the slave agent. Okay, the write sequence you pass to this master sequencer and do the write operation. Okay, and read have to pass to the slave sequencer. You have to access the data, okay, read data. Okay, this virtual sequence will decide which sequence, this write sequence, should be passed to the master agent's master sequence. Okay. So here in virtual sequence we will mention which sequence has to pass to the which sequencer. And here this is a small example, right? So the interface is common. Usually we go for this virtual sequence and sequencer concept when we use more than one interface. Okay. So in the above example, if you see, we have different interfaces like a APP, Wishbone, and PCIe, okay, like that. So then only why we need this concept is we have to pass the different sequences to the different sequences. Okay. So here we have only one interface. So one monitor is enough. Okay, whatever you are writing here, that value can be accessed by this monitor because we are using a common interface, right? So no need to use this master monitor. Whatever you are writing here, with the help of slave monitor, you can capture the right value, and what you are going to read. Okay, so with the help of this read sequence, you can pass the read controls here, and what the data you are getting, that also you capture the help of slave monitor, and in checker you check the input data and the output data. So I will explain how to implement this virtual sequence and virtual sequencer in FIFO code. Okay, are you able to see this window, coding window?
Yes, sir.
So first approach, you have to use only virtual sequence. Okay. So first thing you have to write the sequences. This is a write sequence, and this is the read sequence I have. Okay. So you have to implement a virtual sequence. Virtual sequence is nothing but the container class. You are instantiating the virtual sequence and also the sequencer here. So this is the virtual sequence I am creating. It is extended from UVM sequence. So it is better. You have to parameter the sequence item type. Then here I instantiate the sequences. So I create a write sequence and read sequence, and also the sequencer. Okay. So this sequencer is inside the master agent. Then sequencer 2. So this is inside the slave agent. So in build phase, you have to create object for these sequences, and in task body, I have to mention its sequence, write sequence, and to pass to the sequencer. Okay. This sequencer is present in the master agent. Okay. And read sequence pass to the sequencer 2. Then in test, I need to map. Okay, this sequencer handle I created here, so that I need to map where is the actual sequencer is present. In the test, okay, I have to declare the virtual sequence, and then in build phase I have to create object for the virtual sequence, and in run phase I have to map. Okay, virtual sequence handle is SEQ. So inside the SE sequence, that is nothing but a virtual sequence, I have a sequencer and sequencer 2. Okay, for this I have to map the actual sequencer, which is present in the environment agent 1 sequencer, and this is for sequencer 2, this present in environment agent 2 sequencer. Then here you have to mention null. Here the actual sequences start, virtual sequence dot start null. Why I am giving null? So because in virtual sequence itself I mentioned it should pass on that particular sequence. Okay, this is the first approach. Second approach, using virtual sequencer. So first in the same way you have to write these sequences, write sequence and read sequence. Okay. Then virtual sequence you have to write. In virtual sequence, no need to declare the handles of the sequencer. Okay. Here we are using virtual sequencer concept. The virtual sequencer containing the handle of the sequencer. So here just declare the sequences. Okay. And in build phase or build body, we can create object for these sequences, and you have to mention sequence dot start sequencer. Here we are using virtual sequencer, so we have to mention the handle of virtual sequencer. Actually, this sequencer is present inside the virtual sequencer. So P sequencer is the default handle of virtual sequencer that you should declare. Okay, with the help of the UVM declare P sequencer. So in virtual sequencer, is the name of my virtual sequencer. In virtual sequencer, I put the handle of the sequences. Then here, where is the actual sequencer is located? That mapping I have to done in the environment. In the environment, okay, I declare the instantiate the virtual sequencer. Okay, and in build phase, I create an object for the virtual sequencer, and then in the connect phase, here I map. V sequencer is the handle of virtual sequencer. Inside that I have a sequencer. Okay, the actual handle, whereas the actual sequencer is present inside the agent 1 sequencer. Yeah. Same way for sequencer 2, I connected agent 2 dot sequencer 2. So once you done this one, then test. So test, inside the test you just instantiate the virtual sequence. Okay. Then how to create object in the build phase, and in the run phase just gives virtual sequence dot start virtual sequence handle. Virtual sequencer where it is in the environment we created, right, virtual sequencer. So you have to mention virtual sequence dot star virtual sequencer. So automatically through the virtual, if you mention like this, virtual sequence will start. Okay. So here we mention actual sequence is sent to actual sequencer. So it will happen in this way. So this is the another way you can mention with the help of UVM macros. Okay, instead of writing like this, you can also write with the help of macro. Click UVM2 on. This is the sequence, right? That is the read sequence. Okay, and the sequencer handle. The sequencer, the sequencer dot sequencer. If you want to mention any constraints, you can also write like this: UVM do on with is the macro used to mention which sequence has to pass which sequencer. Okay, along with the some constraints. Okay, this is also available. Okay. So these are the few references. You can refer for further details of UVM. So this UVM, uh, so this Verification Academy and Accelera. In these websites, you can get the UVM package. Okay, you can explore that and you can able to see what are the base classes, abstract classes available. Okay. And these websites also containing the LRM of UVM. Okay, for further reference, you can download it and refer that. Okay, that's all about UVM.